Welcome to Morpheus Chair, the program where you learn to build robots in your comfy chairs. Today, simulation. Wait. I know that a lot of people that work with robotics don't like simulations, but hear me out. If you use simulations, you'll get projects done much faster and much cheaper. Just because if you fail or you commit errors in simulation, there are no consequences whatsoever except spending time. Do I have your attention? Okay, so to the workbench. So hi, and let's start with our simulation. So just remember that we have the repository where all this code that I'm going to show you will be uploaded, so you can download it without any problems and see all the details. Yeah, just because I won't go into all the details of all the simulation, because otherwise this video would be infinite, like 2 hours explaining all the stuff. But I'll try to explain the most important parts and how we connect it with the real robots and the differences, basically. Okay, so let's go. So the first thing is you go to ROS Development Studio and launch the ROSject that I've left the link in the description below. You can also download this code and execute it in your local computer as you wish. ROSDev just gives you a very fast and easy way of having it running. Yeah, especially if you have Mac OS or Windows, which with ROS sometimes give some problems. Yeah. Okay, so let's go. So when you execute the ROSject, just open the ROSject and you'll get something like this. So I'm going to open the IDE and show you the code, and we'll see what we can. Okay, so first things first, I've downloaded the code into this simulation workspace. I've downloaded this, and also there are 2 more Gits that we will use in the next videos and in this one also that you need, which is the person sim and the spawn robot tools. Both of them I link in the video description. The Gits, it's in our repository, it's free, so you can download it, no problem. Person sim is for spawning persons and simulations in Gazebo, and spawn robot tools is just what the name says. It's all the launches and stuff that you need to spawn URDFs, SDFs, chakras, and so on. It makes it much easier than doing it by hand. Yeah, but what we are talking about is this Pan and Tilt Morpheus chair. So we created this one in the previous video, which is Pan and Tilt control, and we have also this Pan and Tilt setup. Yeah, this one is the one that I've created from scratch, which is the Pan and Tilt description. Yeah, all the simulations are. I highly recommend you that you create the description of your simulation in a package called blah 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 description. In here we have basically the definition of the robot, which is in chakras, which is a macro-based URDF system. And then we have the launches that spawn the robot, start the controllers in simulation, start the simulated world, and basically the main one which launches everything. So I'm going to start from here because I think it's the most global. So what we're doing here is launching a world, which is using the empty world from Gazebo ROS, and it's just launching this light world, which is here. Yeah. Light world is just a ground plane and a source of light. That's it. Yeah, very simple. Then we have the spawn of the pan and tilt, simulated pan and tilt, and then the control. This would be creating the object in the simulated world, and this would be turning on. So all the servos and control that the simulated robot has. Yeah, okay. So let's go, how do we spawn it? Well, we spawn it with this one, which essentially uses this spawn robot chakra multiple that I won't talk about. But essentially with this script, you just give it a chakra and it will spawn it in the world with these values. So X, Y, and Z in position, and roll, pitch, and yaw in orientation of the object. Yeah, that's it. So let's see how this is defined. So if we go to Pan and Tilt Chakra, which is this one here, Pan and Tilt Chakra, it's also very clean because you have basically, you are importing these chakras and inside them you have everything you need. And what we do is we initialize a face and the main camera. Yeah, that way we are able to spawn only the pan and tilt, which is the face, and then if we want to activate or deactivate the camera, we can add it here or remove it. Yeah. Okay, let's have a look at the face, which is this one. Face is very simple. It's a base link with essentially it's a box with some variables that are defined in, I think it was common properties. You see, all the properties are defined here, and also the plugin for the control, which we'll talk about later. It's just because if I want to change some variables, I just have to change them here, and then I don't have to mess around here, and I reuse a lot of values, that's why it's so clean. Yeah. Okay, so we have the base link, we have a joint that connects the base link with the world. That way our pan and tilt, simulated pan and tilt, is fixed. Then we have the yaw link, and then we have the pitch link. Yeah. And that's essentially it. So we have also the face link, which is just a mesh to have a reference. We'll see it in a moment. And that's quite it. Let's have a look at the pan and tilt, which is basically what it is. So we have the yaw, which is the pan. It's again a box with some values. And then we connect it to the base link and rotates in the z-axis. And we give it a transmission for the control. Then we have the pitch, which is the tilt of the pan and tilt. Again, the same thing. It's a box with some values. And then we connect it to the yaw. And it rotates along the y-axis. Yeah, just because it's the tilt. Okay? And then we give it a transmission to be able to move it. And then we connect this face link, which is a mesh that you'll see in a minute, that is connected to the pitch link. Yeah? And that way we have some reference to where it's pointing. Yeah? And then we have the main camera, which essentially what it does is connect to the face link, a main camera link, which has no collisions, just because it's a sensor. And then we initialize the camera, which is an RGB 400 by 400, so low resolution, but that's okay for us. And that's it. And then we define the camera name, the topics where we are going to publish, and some values for the camera if you want to change it. These are the values by default in most of the cameras in Gazebo. Yeah. And that's quite it. So enough talking, let's launch it. So we're going to launch and go to Pan and Tilt description, main, and we're going to launch it. Yeah. While it launches, just comment on the control pan and tilt that it's here executed. What we're doing is loading this pan and tilt config, which is this, that initializes the two controls for the yaw and the pitch. This would be the tilt, and this would be the pan, and with the PIDs needed. based on the mass that I've given, the simulation and all that stuff. Yeah. And then we start the robot state publisher to publish the states of the joints, and then we have the controllers that allow us to move the different joints. Yeah. And that's quite it, actually. So I won't go into details just because this is more simulation. Unless you want to modify the simulation, you won't need it. So let's have a look. Yeah, we have it. So our world is just, as you can see, the light source, the ground, and our pan and tilt. So you see it's a head, it's a mannequin head, and this green block is the camera link that we defined here. So if you go to the camera, you see that as visual, we defined a box. That way we know exactly where the camera is pointing. Otherwise, it's quite difficult. It's not that intuitive to understand. Yeah. And that's quite it. So we have the simulation here running. Great. So now, how do we move it? Well, we can move it just by commands. So let me put this here. Whoops. There you go. And here, if we go to simulation source, okay, and ROS topic list, and we grab by command. You see that we have two topics, one for the pitch and one for the yaw. So if we do ROS topic publish into these, for example, the pitch, we double tab and we say, hey, 90 degrees, I think. Oh no, I think it's in radians, so it's around 1. There you go. So that was a pitch. And if I do ROS topic publish and I publish into the yaw, which is the pan, if I put here again, for example, -1 would be minus 90 degrees, more or less. There we go. So we have it there. Yeah, easy peasy. Okay, but this is a bit, okay, it's very basic, but we have the simulation working. This is step 1. Step 2. The step 2 is connecting this simulation to our previous code and the code that we use for the real robot. That way, what we develop for face tracking and everything, it will work in simulation, but also in the real world. Yeah, that way we will do all the tests and stuff in simulation so that we don't have to have a person there standing all the time. And when we have it working, we just change and say it's not the simulation, it's the real thing, and it should be transparent. It should work exactly the same. Yeah, so pan and tilt control. You remember what we did? Yeah, you remember that we had a pan and tilt message, custom message, and we had some launches to do that, to launch the server. So as you can see, we have 2 new launches. One that it's called Pan and Tilt Server Sim, and one that it's called Client Sim Test. Yeah. Let's have a look at the server. It's exactly the same as the one for the real robot, just from that in the simulated we state simulated and that it's not in the Raspberry Pi. And in the real one, we say that it's real. It's very, very intuitive, this way of doing it, yeah? So this basically will start this Pan and Tilt server with these values stating that it's simulated. So let's have a look. So Pan and Tilt server. Okay, let's give it a little bit more space here. So what have we done? Essentially here, the only thing that we've modified is this, that we talked about in the previous video. We stated that if it's simulated, we are going to initialize this pan and tilt move sim instead of this pan and tilt move. And we initialize it with the same name. That way we can use it inside here with no problems. Yeah. The only other thing that I've modified is the fact that we have to state here that if it's simulated, then we move. Because remember that we had only this, if it's inside Raspberry Pi, then we send commands. Otherwise, we wouldn't send any stuff. This was for testing. But we need this because when we are in simulation, we need to send this. Yeah. So it's exactly the same. We just had to change 2 lines, or had 2 or 3 lines. The thing that has more work is this pan and tilt move sim, which we have here. So we have pan and tilt move, which you remember that we did in the previous video. And then what we've done is that we copied this. So we have the same structure, we have the same API, let's say, the same functions, the same methods to access and move the robot, but we move it in a very different way. So in the real one, we were connecting to the Raspberry Pi and using the PCA library and all that stuff. In simulation, there's nothing like that, because to move the simulated pan and tilts, we have to publish in these topics that I just showed you how to publish. Yeah. Apart from that, there's another modification that we have to do, which is when we move the pitch or the yaw, the yaw or the pitch, we have to convert the angles to radians, because again, here you saw that we were using radians, so we have to publish in radians. Yeah. Apart from that, there's no other modification that I remember, that I recall, and you see that it's exactly the same thing. So we can execute this and do the test of the circle exactly the same way as we did in the pan and tilt. Yeah. Okay. Then, to do this, what we're going to do is we created this pan and tilt client sim test, which again launches the server simulated, and then we're launching the exact same client. We didn't modify it. If you remember the client test, it's exactly the same. Why? Well, because we're using a server, basically a ROS topic subscriber, we just publish there. And it doesn't matter for us if it's a simulated robot or the real robot. And that's the power of ROS. That the person that developed this client, he doesn't care. He or she doesn't care if it's real or simulated. So let's go. So now we are going to ROS launch, pan and tilt, control, and then client sim, and there we go. So it's starting, and now it's doing the circles. As you can see, it doesn't behave exactly the same way as the real one, because this simulated has more mass, for example, so it's slower than the other one. Yeah, but it makes my point. So now we can move it around. So the pan, I don't know, 0, and the tilt 0. There we go. So now we have the there. Now, for example, minus 45 degrees in the pan, and tilt 0. There you go. And another thing that we can do is see the camera. So ROS run RQT image. You can do exactly the same thing in your local PC, just that you'll have to set up and maybe install stuff. We open the graphical tools. There we go. So let me do it a bit bigger. There we go. So we select the camera. In this case is the Pan and Tilt Image RAW. And now to see the differences, what we're going to do is we're going to add some objects here. There we go. This is the power of simulation, that we can modify the environments and have very complex environments free and very fast. So let's, for example, 0 and 0. There you go. Now let's go down. So pan 0 and this one 45 degrees. There we go. So now for example, 90 degrees and 45. There we go. So the cylinder. And yeah, that's quite it. So we will use all these tools in the next video to make the people tracking. Yeah, we will spawn a person, a virtual person, and we will try to track their face with the pan and tilt. And that's all for today. Thanks a lot. Smash that like button if the video was useful for you. And remember that on June we have the ROSDevelopersConference, the second time that we do it. So you can buy your tickets, link below. And yeah, next video, what we're going to do is face tracking. So don't miss the next video. Until then, keep building.